So the space project is going to be what we build here, and the first thing we need is space. We're not going to be able to do a whole lot without a world to practice in, so I'm going to create my subclass here, and you call it what you like. I'll call it space, and I've got an image. You can also grab it. All I did was grab it from backgrounds, so if you're trying to follow along, it's right there. But I'm just going to I tried to set up as much as I could, obviously, so we don't have to talk about, wait for me to download things on the internet. And when you compile this, that's the size of the space. But the background for space is actually pretty consistent. So if I wanted to make this world a little bit bigger, like maybe 800 by 600, I don't want scrolling bars. That's kind of annoying. But let's just see, if I make it a bit bigger, can I get away with it? Yeah, it looks like I can get away. It fills my screen a bit more. Just gives me more playroom, let's call it. All right. Now, you should know that probably the biggest factor in determining the success of software is planning. So in this course, we basically just run into things, right? We just start programming, and that's not the way it happens in the real world. Usually, if we were to say it was going to take a year to build this software, we would probably spend 8 months planning and engineering it, and then the last 4 months we would actually go code it. Again, if you think about it, this is like you would be saying, I'm going to build a house today. Let me grab my hammer and nails and just start nailing boards together. You're not going to really have a good plan. The house is not going to turn out as well as if you put down all the tools, draw up some blueprints, and plan for that house first. So you're going to see me going and doing some stuff because I've done a lot of the planning in this game ahead of time, which means we need to start with some utility classes. And the first thing, which is common to most people's games, is they want some way of making a text label. And that's what I'm going to do here. This is going to become a scoreboard in your game. So for me, I'm going to call this class the label class. And it's a scoreboard. I should be able to tell it what I would like it to look like. I don't want it to be, it wouldn't make sense if the label was just an animal like a dog or something, right? So in that case, it wouldn't make sense to click on it. We just leave it undone. We don't put an image on it. We just say, okay, we're going to create a label, and there's no image fixed to that label. So now we're going to dig into the code here, and I'll show you how you create a label in Greenfoot. And what I'm going to be doing is manipulating some of the methods that are already available to me from the Greenfoot image. So I've got that here. I'll pull it up for you. So the Greenfoot image class lets me draw pictures on Greenfoot. And one of the things that I can do here creates an image with a given string. That's what I want. I want to give Java a string and have it draw it on the board for me. So that's what I'm going to take a look at here. I can see the details. Okay, the font size, requested height in pixels. Let's see here, string, foreground, background. So in our, I guess if you're thinking about what am I doing here, the foreground is the text itself. The background is the area behind the text. So there's a couple defaults here. If I don't give it anything and I just say null, and I say no color lives here, it will use black. And if I say no color is used in the background, it'll be transparent. Okay? So that would be great, except space is black and we won't be able to see this label. Okay? So we'll talk about how we can specialize it later, but we need to keep track of those things right now, and I'm going to make my label remember them. So my label should know what is your text. So I'm going to call it label, and I like to use an underscore with my instance variables because it helps me when I'm looking at my code. If I see an underscore at the very end of it, I know it belongs to the instance variable, not just any old plain variable. The other things I had in there was an int called font size. And you see here how it says a color? It's actually telling you where to find that color. So it's saying it's in the Java AWT color package. So let's go pull that into our code. And this is the process of reusing code. We're going to say import java.awt.color. So this lets me use the available class rather than reprogram and recode my own. This is something that all good programmers should do because you don't want to reinvent the wheel every time you have to create some code. You won't get very far. So I'm going to make a color here, and this is the text color, or what Greenfoot calls the foreground color. So I'm going to be more specific and go like that, call it text color. And I'm going to make another color here called background color. Background, sure. Something like that. Something, again, which is readable to you. You could, maybe I'm being a little bit lazy here. I could have called it background color. But you'll find that most programmers abbreviate their variable names. So I can already tell I'm going to get annoyed by this, so I'm going to just call it background color. Okay, welcome to the world of programming. We're lazy, but not so lazy we wouldn't understand what the variable name represented. Okay? It is hugely to your benefit to pick good names. Otherwise, your code is going to be really difficult to read and understand. Now, I'm going to tell Java how to build a label, and to do that, I need a constructor. So here's the constructor, and again, how do you know it's a constructor? This is something we've talked about in our first unit. Label matches the name of the class. This is where all labels are built. So before any code runs, Java goes to this and builds you a label. So here's what I'm going to do. I'm going to say super. This isn't the way of telling Java. This is an awesome constructor. This is the super class. The super class is the one above it. So I'll show you what happens here. Here is super, one above. So it follows that arrow and goes one up. And what it does is says, hey Java, before I start using myself, I would like you to take my parent and build one of them. So that's saying to Java, build an actor. So now I can use everything from the actor class. Oops. From the actor class. You'll find that you may get an error if you don't use this first by building the parent. Okay? So anytime you're going to use the parent's methods, which is a good thing, first you got to build the parent, and that's how you call it in Java. You say super. Super can actually access any of the parent's methods as well, but we won't talk too much about that because we're just getting started. So I would like to be able to give you some text and Java draw that for me. So this is called a parameter. I'm going to put that in there as text. What text does this label represent? You pass me the text and I will assign it. So I'm going to say the label that this actor remembers is going to be equal to the text you give me. We will set the other variables up in different methods. So what I'm going to do right now is give it some defaults. Font size is, let's try 24 pixels. Text color is equal to, and if you're kind of wondering, how do I build colors? I'm going to help you with that right now because you're going to want to start customizing things, and that's one of the basics of customizing graphics is knowing how to build a color. Some colors are predefined. For example, if I say color.red, this will give me the predefined color red so that Java knows how to draw a red pixel on the screen. And this capital convention means it's a constant. You wouldn't want someone to go and change red because then the code wouldn't make any sense if blue showed up. So when we make things constants in Java, we use all capital letters. If you're reading someone else's code and it's all capitalized, that would mean it's a constant and you're not allowed to change it. If you try something crazy like this, you don't need to put this in your code if you're following along. Java will say, you cannot do this because red is a constant. It guarantees that no one can change the value. So constants are a really good programming practice, and we use full capitals to dictate that this is the style for a constant. The keyword for a constant is final. Changes its color. That's how you declare something as not changeable anymore. Okay, so a lot of stuff there, but let's keep going on our original purpose, which was building a label. And the background color here, I'm going to use the color constructor. So I pulled up that documentation to show you what can you do with a color. Here are the constructors for a color. This is the different options you have for building. And the color scheme that I'm going to show you is these two, red, green, blue, and red, green, blue, alpha. So these are how your computer works to build a color. It takes the colors red, green, and blue, and just like in primary school when you stuck your fingers in paint and mixed them together and then you went, ooh, red and blue makes. You didn't do that lesson in primary school? Red and blue makes? Purple, thank you. That's how you get purple on the screen, is you mix red and blue together. So I'm going to show you one way that you can play with colors, and that's the most high-power, awesome graphics software available to you, which is called Paint. One person got my joke, thank you. And when you ask for a color in Paint, there's an option here to edit your colors, and this will show you the red, green, and blue components. Okay, so for example, you might say, ooh, that's a pretty color. And when you click on it, you can pull up, let's go this way. If I wanted to recreate this on the computer screen, the components are red 221, green 66, blue 198. So now I can make custom colors and tell Java what the numbers are that go with it. It's pretty hard to know what they're going to turn out on their own without some practice with what the different mixtures make. But you'll get the hang of it when you practice lots of graphics, but it's not necessary to memorize. All I would expect is if I go like this and I said all red, no green, no blue, well, there shouldn't be much surprise that the color that comes out of there is a red color. What happens if I take some red off? Well, when I lose less red, does anybody know what happens when there's no color? What color do you get when you take them all away? Black. You get a darker version of red, you know, until it starts getting so dark, whoops, that it starts to resemble black. And in fact, no colors gets you black. All colors, anybody know what all colors is going to get me? Yeah. So all colors in the spectrum get you white. So that's how you can fool around with custom colors. The other thing is the alpha component. And the alpha component is how transparent you want it. And it's a number, same as it is there, from 0 to 255. And what that represents is how much transparency your image should have, or the opacity, how opaque it is. If you're at 0, it's completely see-through. Doesn't matter what color it is, it won't be rendered because it's completely transparent. At 255, it is completely opaque, which means you cannot see through that color. So somewhere in the middle, you would have transparency where you'd be able to see a little bit through your color, and background objects you would pass through. You'd be able to see behind it. So for me, I like the idea of having a transparent background. So what I'm going to do is create a color. It's white, but it won't show because I'm making it transparent. Okay, so my default label has a red text with a transparent background. Okay. Every time I draw this, I'm going to do the same thing, which tells me I should have a method for it. So the process would look like this. I'm going to make a Greenfoot image. And I'm going to construct it from my label, from my font size, from my text color, and from my background color. Then I'm going to tell Greenfoot to set the image of this actor to the one I just built. So this process will be repeated every time I change this label. So rather than copying and pasting my code, which should tell you right away, if you copy and paste code, it should probably be a method. Because if I copy and paste this in 10 places and later on I find there's a bug, I have to track it down in 10 different spots. So instead, what I'm going to do here is make a method. So I'm going to say, instead of doing this again and again and again, I'll say update the image. Now I know anytime I change one of its instance variables, I'll have to update the image, but that's all I say. Update the image, please. So let me give you an idea what that means. Someone could say to me, public void, and maybe they want to change this label. So I say, no problem. You give me the new text that you would like, and I will update what this label shows. But right now, the label knows that it's changed, but it hasn't drawn it because I haven't asked it to do this. Okay? So this basically will take the new value, change it, and then request from Greenfoot that it updates the image. I'm going to do this process every time I change something. So for example, public void set font size. So now the font size that belongs to this actor is going to be the one you just gave me. And the label is quite happy to change that. But Greenfoot doesn't know anything about it because I haven't said update your image. But you should already see the fact that that method's a good idea because I've used it over and over and over again. But now I only call the one thing, update image. If there was ever a problem in Greenfoot and it wasn't updating properly, I only need to look here to find out what my problem was. And everybody else is automatically fixed when I fix this code. Okay, so I'm just going to put the rest of the change methods down. Okay, so now I have a way of accessing all four of the things a label remembers. A label remembers what it displays, how big it displays it, and the colors that it displays. And it's a pretty boring Greenfoot character because it doesn't do anything when it acts. It just sits on the screen and shows us what it has. So let me, I'll actually let you see it in space now. I'll compile my code, and hopefully everything is okay. All right. And what I'm going to do now is ask for a new label, and I'll put it in here so you can see the code actually doing its job. When I click, I can't actually put it in the world yet because it wants to know what is the text you'd like. So up here, remember I said, you tell me the text, I will draw it. So there you go. There. I put a message into space for all of you to see. So now that it's rendered, it says hello ICTP 11. Okay? And we can do all kinds of things to it. Like maybe I say, you know what? I don't like that. Let's make the font size. And it says, sure, you can change it, but please give me that value. Let's try 50 pixels now. I should now see this image get bigger. Okay? The label we've created is your template for building a scoreboard character. I'm going to create it with you, but you're going to have to fill in the methods. So that's what we'll do right now. A scoreboard is a kind of label, but it is a special one that only keeps track of the points, right? So let's go down here, and we're going to subclass the label because a scoreboard is a label. And again, I don't have an image connected to this one. It's just going to display the points on this game. So I'll go into scoreboard, and I'm going to spell out for you what your job is in using my class. So here's the constructor that I'm going to ask that you make use of. First, I need a score. My scoreboard should remember the score, or it's not going to be very useful, will it, right? It has to keep track of that, or it won't know how to tell the game what's happening. So then in here, I'm going to make a public scoreboard. And this is how I will build my scoreboard. And I should probably set, what do you think? When the game starts, usually the score is 0. Thank you. So if the score is 0, I should reflect that. When you build the scoreboard, it starts at 0. Okay? Now, when I do this, I'm asking the label, the parent class above me, to build itself. Sorry. I should make that the first thing. I'm going to switch that, sorry. Got carried away there for a second. The reason I want to do it first is before I start using a scoreboard, I have to build a label. A scoreboard is a label. If I don't build the label, it doesn't exist yet for me to use it. So if I think about what would I build, I need to know this is what I'll display. Score is 0. What I would like is a font size and a color. Maybe I'm happy with the default, but if not, you can redefine it. That'll build a scoreboard that starts at 0. So your job in here is to add these methods. One where you can update the score. And one where you can clear the score. So I'll give you a couple comments so that you can think about what code you might type in here. So to update it, this makes me add the value change to the current score on the board. So that way in your game, you just shoot an enemy, you get 10 points, you can say update 10, meaning add 10 points. Maybe you get hit by somebody and you say, oh, that's 5 points off your score. So you'd say update -5, and the scoreboard would take 5 off. Clearing the scoreboard, make the score equal 0. So if you're specializing my label class, this will give you a scoreboard that you can now use in your game. It's likely that when you want to put a scoreboard in, you're probably going to, tuck it up here in the top corner or something like that. Okay, so the first utility class that you guys should all have and test and make sure it works the way you like it is a scoreboard. Feel free to add to this class other methods, other variables, whatever you think would be a nice feature, but don't duplicate what the parent already does for you. For example, if you want to say, oh, I'd like to change the color, it's already there. Because a scoreboard is a label, it's going to get everything a label has for free. If I compile this and put a scoreboard, just laggy when I'm recording, sorry, and put a scoreboard in the world, I'll drop it off, and it starts as a 0. When I right-click on it, you can see there's the methods we just talked about, clearing and updating the scoreboard. You can test them. And here's the ones that are inherited from the label. So maybe I would like to change this font size to 50, like we did before. I don't write new code, it's already there. So now that 0 is going to get much larger. I can do something like, if I call update, if yours works properly and I say update 10, that score should go up by 10. Nothing's going to happen, of course, because there's no code in there. Okay, so that's where I'm going to leave you to do your first utility class for your game that we're going to keep stepping through piece by piece.